So last class we discussed about compiler directives and then how the tick time scale it is utilized, time unit by precision, and then so related to time scale and then tick include, tick define, all these things we have discussed, right? So these are the compiler directives. Tick undefined means it will remove the whatever defined file is there, that will remove that. Okay. So today we will discuss about parameter overriding and then Verilog parameters. Okay, what are the parameters? Why we use the parameters? Okay, so parameters are generally generating the constants. I told you in the yesterday. So we have taken the width, data width, and address width, all these things, right? Okay, so at that time we will use these parameters. See, parameter is a compile time constants. Okay, whatever the compile time constants means, so during the compilation it will use the constants like this, like width I will take that. Okay, so width is taking like 8. That means whatever the parameter, whatever the variables you are considered in your module, okay, so those will be in the constant number of 8. Suppose in my module, this is my module, some half adder I am taking here. Okay, so this half adder or full adder you can take. Okay, so full adder you can take that. In that full adder, each and every variable it is capable to 3 bits we are taking. 3 bits means 2 power 3. Okay, so 2 power 3 means 8, right? Yes. Okay, so 2 power 3 means 8. Then just give me a minute. Okay, so I told you parameters are used to produce some constants. Okay, what are the constant means? I'm taking some variables like module full adder I have taken. In that input wire you are taking. Okay, input wire, some width I need to mention. Okay, so width minus 1 down to 0 of a. Okay, so this width value how I am representing means here I will take hash some parameter. Okay, so parameter I will take that parameter is maybe width. Okay, so then width equal to 4 I will take here. Okay, so then width is 4. Then here every time the value is 4 minus 1 down to 0, it is considering that 4 minus 1 down to 0 means what? 3 bits, right? So 3 down to 0. Okay, 3 down to 0 means what? 4 bits. Okay, it is taking that 4 bits. Okay, so 4 bits means up to 2 power 4. 2 power 4 means 16 values it will be taking. Okay, this a is capable to store 0 to 15 values. Clear? That is the reason we are taking the parameterized modules. Okay, why we need to take the parameters means parameters are the constants, so we need to customize our module. Okay, so the use to customize our module means sometimes I want to customize my module to 8. Here width is 8 I am taking, and then someone came that and then please increase the number of bits 16. Okay, is that possible? Yeah, it is possible. Just change this width 8 to 16, then it is converted to everywhere. So wherever you are utilizing that a variable, then it will be taking that. Okay, then how this tick define is utilized here? Tick define, Then tick define width I will mention, then width is equals to 8 I will mention. Every width, wherever width is there, then you can use this tick width. Okay, so tick width minus 1 down to 0. Then everywhere it is changing, just I am changing this defines file, then it will automatically appears in your module. Okay, whatever the module you are considering, okay, in that module it is automatically replacing that. Are you getting my point? Okay, so if you are considering this width and depth, all these things, see in your module, see, just give me the this is my module, like how I am representing the parameters link, module name. Okay, in this parameter I will consider, parameter is the keyword, and then width is the constant. Here width I am taking 8. Okay, wherever I am taking the input data, so that data is uh, parameterized data, then how it will be considered here, my width is 8. Okay, so 8 minus 1 down to 0, it will consider that, means that here width is 8 means then input should be 7 down to 0. Okay, 8 bit, and then your width is 16, then your input should be 15 down to 0, that means 16 bit. Okay, so this constant will tells you how many bits you are considering in your module variables. Okay, whatever the module variable I am taking, okay, in that variable some bit you are mentioned, some parameterized constants you are mentioned, that parameters tells you how much capable to store the bits, or how much the capability of the variable to store the values. Okay, so that is the main thing. See, why parameters are important means, without parameters every time we need to use size, every modules for every size we need to code duplicate values, right? So because code duplication is maintained, so that duplicate we are using means that is difficult to maintain. Okay, because I am written some code related to 4 bits module. Okay, 4 bit module, then someone came that and update that it is to 16 means, so again I need to write the code and all these things, it is difficult to maintain, right? So that is the reason with parameters. So one reusable module, okay, whatever the module we are using, that will be reusable. One module I am utilizing, then this module only I am reusing that. Okay, and configure that according to your specification, I will configure that. Okay, whatever the RTL you are writing, that will be scalable, that means I will manage the constants. So that is the reason we are using these parameterized modules. Okay, see, here one adder is considering that. So A, B values are width minus 1 down to 0. B value is also width minus 1 down to 0. Sum is also width minus 1 down to 0. Here adding of two numbers is the same width. Okay. Then result also we will get the same width. But multiplication you are taking means, then you are taking the multiplication means you need to multiply this width. Okay, 2 into width minus 1 down to 0. Okay, so then your width should be multiplied 2 times. So 2 into 8, what is that? 16 minus 1 down to 0. That means 15 down to 0 it will be considered. Clear? See, if you are taking whatever the arithmetic operation, depends on that your result bit may be varied. Okay, so your bit you are taking some means, so 4 bits I will take here. So 4 tick A is 8 bit, right? 8 tick binary 1 0 1 0 1 0 1 1, and then B also I will take that 8 tick um, 8 tick binary 1 0 1 1 0 1. Okay, so 0 1 I have considered here. Okay, so then add these values. So 1 plus 1 means 0, and then 1 is there, and then 1 plus 1 means 0, 1 is carry, 1 plus 1 means 0, 1 is carry, 1 plus 1 means 0, 1 is carry, and 1 plus 1 means 0, 1 is carry, triple 1 means 1, okay, 1 is carry, and then 001 means 1, 1 is carry, 1 1 means 0, okay, so 1 is carry. This will be considered as a one number and this will be considered as a other number. Okay, so this is 1 and then this is what? So 1 2 4 8 16 32 64 128, depends on that it will be taking the values. Okay, then your sum will be storing as the same width of values. Okay, if you got any carry at that value, it will add to the, it will take the another number. Okay, it will take it as a another number. Clear? Any doubt in these parameters, how I am utilizing the parameters? Now how to override this parameter? Okay, so there are three methods are there. Passing constant values. Okay, so passing constant values means, see this adder, some value I have taken, this is my adder example. In this the width is 16 I am taking, then which are the variables you want to change, you need to mention the variable names. Means that compiler change the width to 16 for every instance, for this instance only. Okay, so that means you are taking adder is equals to 16 of a, so whatever the a you are taking, a2 you are taking, for that instance only it is changing the value. Okay, so that is one method, that means passing constant values. See how I am passing the constant values. Example like this counter I am taking that. So that module. So parameterized class you need to take that, or parameterized module you need to consider hash. Okay, whatever the module is there and module name, after that you need to consider hash. Okay, so my module is why is the module is used, module is a basic hardware unit, right? So that is the reason we are using the module. Module name means, so you need to identify the name. Okay, what is the name of my module? Okay, then I will utilize this parameter width. So width is everywhere here, so width 4 down to 4 minus 1 down to 0, and then what is the reason here 3 down to 0, then here value is 4 bits, the counter value is being 4 bits, then how many times it is storing the values, up to 15 reaching, then it will be ending that. Okay, but this always passage clock is never ending here. Okay, for that you need to take some condition like count, so if my count is greater than or equal to or less than or equal to 5. Okay, after that if it is reaching the less than or equal to 5 means only 5 counts only it is counting, or if you want to count more than 5, then if I am taking the count less than or equal to 10, I want to take that. Okay, so then up to 10 counts it will be counting that. After reaching the 10, whenever it is reaching to the 11, so the condition is fails and terminate the loop. Okay, so this counter will be increased infinitely, what it called, running. Okay, the simulation is running infinitely because the counter is there is no ending here. Count equal to count plus 1, it will be increasing. Okay, so you need to end, that means I need to take some condition, then only it will terminate the counter. Okay, so just counter, how we need to write the counter means module, module name, parameterized module I am considered here. 4 is I am considered. Input is clock and then output is counter. Okay. So sometimes they will ask you some registered input you need to consider. Okay. Registered variable you can consider. This count will be acts as a registered variable. It is counting that. Okay, so then because this is the range, some count I am taking width minus 1 down to 0, I'm not giving any value here, just counting the clocks. For every clock pulse, I want to count the how many clocks are generating. That is the reason I'm taking this counter. Okay. See how the instantiation is happening. Counter hash 8 and then C1 of clock comma count. See, this is the instance name, right? So for this instance only, I will utilize. Then this module is changed to 4 to 8. The width is changed. The module name is counter, right? So my module name is counter. I have taken the counter hash 8. Okay, hash 8 and then C1 is my name of the module. Okay, just simple name of the module, that means updated module. Okay, so previously I have taken the module name is counter. Okay, then C1 is the updated counter. Then this C1 is taking the values like clock comma count. This will be considered the parameterized module is 8. Are you understood? So counter is my module name and then I am changing that parameterized to 8. Then the module name is changed to C1 here. Whatever the variables you are considered in your old module, okay, you need to write here clock comma count. Then all the variables will be updated to parameter called 8. Okay, so that is the meaning of this. See how to name the parameter style, like see how to override that instantiation. See, this is my adder, right? Some adder is that taking me here. So this adder hash dot width of 16. Okay, so dot width of 16 means, so you are taking the parameter is 8, right? 4, right? So then I want to change that 16. Okay, so then after the module you need to instantiate your parameter. How you can instantiate? Module name hash. See how we are instantiating your module in your DB, right? Tell me. So this is my module. Okay, so module counter I'm taking here and then input wire you have taken some A and then input wire you have taken B and then output some range you are taking C here. Okay, how you are instantiating your module in your TB? So just take the module name. What is the module name? Counter. Okay, take the same counter and then user DUT you are taking that, right? Some name, your name. Okay, so the counter and then user DUT, inside that dot A of A you are mentioning. Okay, that is the name based instantiation, right? Dot A of A comma dot B of B comma dot C of C. In this way you are instantiating, right? Same way I need to instantiate my width. Okay, width is my DUT. Okay, and then this 16 is the changing parameter. Okay, so the size is changed here to 16. Okay, whatever the A2 variable you are taking, all these A2 values will be changed to 16. Okay,
Yes.
clear? Are you understood how I am overriding? Suppose I want to override this to 32. Same way, adder you can take that hash. Okay, so dot width of, okay, 16 you can take as usual, comma, and then dot width of 32 you can consider. Then it will support 32 as well as 8, sorry 16, and then 8 also support. Okay, 4 also supports. So you are instantiating to higher width, then below width automatically supporting that. Okay, whatever the below width you are taking. Okay, so that means 32 below width, what are the 16, it will be support. 8 it will be suppose, and then 32 is also suppose, 4 is also suppose, and I want to change again this module to 64. How I need to represent that again? So dot width of 64 you can take. Okay. So that is the parameterized overriding method. Okay. So second method is, I told you, tick define macros. Okay, in the yesterday class we have taken the macros, right? So tick define, this is the data width. Okay, so what is that? Data width. So this is the data width I'm taking, that is 32. Okay, so then instantiation adder hash tick width of a3. Okay, so tick width of a3 means whatever the 32 you are taking, that will be applied here. Okay, so just you need to change this compiler directive width only. Previously I'm changing the width in my module, and then I'm overriding the width. So that is I have considered. How I'm overriding means dot method I'm utilizing that. That means name based instantiation I'm utilizing that. Okay, so not the ordered based. Okay, name based I'm utilizing that, and then I have to substitute my configuration is compiler will substitute that 32. Suppose you want to change to 64, just remove this 32 and then here change it in 64. Everywhere it will be changing that 64, because tick width will takes place in each and every place. Okay, so tick width it will be takes place in every place. So that is a centralized configuration. Okay, so why we are using this tick define means, so if you change one variable, then it will be applicable to each and every variable. That is the centralized variable. Okay, another way, so we can use that def params, define params. So tick define we are used that. So this is the old style method. We are not utilizing this one. So this is the best case. Okay. Most of the designers are utilizing this one only. Okay. In this way, easily identified that. Okay, which width we are utilizing all these things. Okay. See, how it is considered that adder. I'm taking the name is A4. Okay, A4 dot width equal to 16. So for that I'm using the keyword called define param, def param. That means define parameter. Okay. So def param is used that you are defining the parameter. So that means define parameter. Okay. You are defining the parameter. See, this will be changing everywhere. How it is changing means, so this is the instantiation. After instantiation, change parameter value hierarchically. That means hierarchy based, it will be changing. That means one module after that other module, it will be changing. Okay. See, compiler transfers hierarchy and then modifies the parameters. Okay, so because define param is used at, okay, def param you are utilizing, then it is everywhere, it is automatically changing the value. Clear? See, this is the preferred way. I told you now, preferred method is hash dot width of value. Okay, so that means dot width of some 16, or I want to utilize another parameter dot width of 32, or I want to override this one dot width of 64. In this way you can override it. Okay, that is the parameterized overriding technique. Okay, so this is the example. So simple example I am considering here. FIFO depth and width. Okay, so this is my memory. Okay, in this memory, depth means what, width means what. Okay, so depth means your storing capability, right? So here my depth is 16. Okay, 16 minus 1 down to 16 minus 1. Okay, so that means 0 to 16 minus 1 means 0 to 15. So my FIFO width is capable to store 0 to 15 values. Okay, so each place how much capable to store means 2 power 8 value it will be capable to store. Okay, 2 power 8 means 256. That means here also I can store 0 to 255. Here also I can store 0 to 255. So suppose I am storing the 0th position some 155. Here 100. Here 120. Here 130. Here 90. Here 70. In this way my bit is capable to store different values. Clear? See, this is the way I'm storing the values. See, 130 is stored in one variable, one place. So up to 16 capability is there. Depends upon the width. Now someone came that, can you modify my FIFO size? Okay. Yeah, it is possible. If you want to modify your FIFO size, then it is changed to say 16 to 32. Here only you can change, or you can change by using this method. Okay, so this is the instantiation. What is your module name? FIFO, right? So FIFO is my module name, and hash. What are the parameters you are utilizing in your FIFO? Width, depth, and width, right? So then I am taking the depth. Depth is changed to 64. Then width is changed to 32. 32 means what? 2 power 32, right? 2 power 32 means how much it is capable? 2 power 10 into 2 power 10 into 2 power 10 into 2 power 2, you can write that. So 2 power 10 means 1 kb. So this is 1 kb, this is 1 kb, 1 kb, 1 kb, 1 mb, 1 mb, 1 kb, so 1 gb. So 4 gb data it is capable to store. 2 power 2 means 4, right? So then 2 power 2, okay. So 4 GB data is capable to store in each location. So crores of data it will be stored. So in this 0th position, it will capable to store 0 to 2 power 32 minus 1. Okay. So 0 to 2 power 32 minus 1 value it will be stored. That means 1 lakh you can store that. Or 10 lakhs you want to store, you can store that. Okay, just give me 2 minutes, huh? Okay, up to this is okay, right? So how I'm overriding the parameters? Okay, so most of the times you will use that parameters to global override methods only we will use. So this is global override method. Okay, so then whatever the FIFO you are utilizing, that would be the global overriding method here. Okay, so in this way I'm changing the parameters. Okay, see, uh, what are the Verilog constructs means? So that is the compiler directives like parameters versus macros. Okay, so parameters are always taking the Verilog constructs. Constructs means so some parameter names, keywords you are considering, right? All these are related to constructs. And here compiler directives we are taking that. Okay, that means tick define, tick include, okay, tick not defined, all these things we are taking. Here, most of the parameters are implemented in the module side. Okay, if you are taking the parameters, sometimes local parameters are also there. Okay, local param you can mention that. So how we are mentioned def param, define parameters, same way local parameters are also there. Okay, so we will represent that. That is the scope of module. Here every time module only we are mentioned. Here globally we are mentioning that because tick define is utilized in everywhere. Okay, in each and every module you can use this tick define module. Tick define width you are mentioning that. Okay, this width will be assigned to each and every variable. Okay, so then it is safer and sometimes it is some risky is there. Okay, because I need to take care of that each and every variable. Okay, so sometimes we will use these macros after the designing the module. Then whatever the parameters you are utilizing, that we will consider one module like defines.v. Okay, so defines.v file we will consider that. This defines.v will tells you what are the different parameters you are utilized in your module. Okay, so that will be taken care by this defines.v file. Most of the cases we are utilized in designing a hardware. Okay, and then here some processing purpose and pre-processing, post-processing purpose we are utilizing this one macros. Okay, so variables and parameters are also see constant you are changing. Okay, parameter is a constant, variable means changing during the simulation time. That means you are taking a b c. Okay, all these are variables. Okay, during simulation time you are changing the value. Okay, a equal to 4 tick d10 or b equal to 4 tick d5 or b c is equals to 4 tick or 8 tick d 25. In this way you are changing the variables, but here constant. Okay, throughout simulation you are maintaining the constant values. Okay, so this is executed in the runtime. Okay, so runtime means simulation time, compile time means it will check the syntax errors. Any syntax errors are there, that will be taken. So change cannot change dynamically because during runtime we cannot change. Okay, whatever the parameters you are utilizing in your RTL, at that place only you need to change, otherwise it is not changed. So here we can change the runtime variables. See, one time I am changing the variable, other time I am changing the another variable. Okay, some delay you will give that. Okay, after that delay a value will be changed to 1 5. So 1 and 5 8-bit number decimal value, in this way it will be changed. Okay, see, these are the local parameters. Local parameter is that you are utilizing the same module only. Okay, where we are mentioning the local module, local parameters means suppose you consider some module FIFO. Okay, so in this hash you can use, and then width and depth you are utilizing. Okay, so these are global parameters. Inside the module, whatever the parameters you are utilizing, width and depth, so width is 16 and depth is 64. In this way you are utilizing. After that I will utilize another parameters like input, some width minus 1 down to 0. Okay, in this way variables I will be mentioning. Okay, all these are global variables. Then after closing the parameters, okay, so this my module ends there, brackets close and semicolon means my module parameters are closed. Okay, and then below that local param. Okay, so the keyword is local param, I will utilize that. Then the local parameter address width I'm utilizing there. Okay, sometimes I want to change my address. Okay, address width is changed to 16. This 16 is applicable to in this module only. Okay, local parameters are applicable to their current module only, and you are not utilized in the other module. Suppose I am utilizing this FIFO in my memory controller. Okay, so module, some memory controller module I'm taking. So some inputs I have taken considered here, inputs and outputs. Okay, so then after that my modules are ended, then I am instantiating this module, okay, FIFO module in my memory controller. Okay, so then these modules parameters, what are the parameters which are there, that will be utilized in this memory controller. But these parameters, local parameters are there, that is not utilized in this module. Clear? Global declaration and local declaration. Local means in the same module only you can utilize, and some other modules you have in that modules you can utilize your global parameters only, not the local parameters. Okay, so these are the memory tricks you want to remember. Okay, see what are the things we here we mentioned. Parameters are configurable constants. Okay, every time you can use the different parameters. Okay, sometimes I want to utilize overriding techniques. Okay, hash some variable, you can use that, means that is the override value. Okay, and defparam is the hierarchical override. Hierarchical override means different modules you can use that. Everywhere I want to utilize the same parameters, then def parameters you can use that. Local parameters are fixed internal constants. Okay, so same module you can fixing the some values. That is the local parameter. Okay, so local parameter cannot be override. Global parameter can override. Local parameters we can't override it. Okay, remember that. So this is the summary. Verilog parameters are used in compiler time, that is making the RTL module, and then reusable, scalable, all these things. Unconfigurable module we are using, right? That is the reason parameters are utilized. So why we are going for the parameter means, instead of separate modules you are creating for different widths and depths, all these things. So same customized behavior we are utilizing there. Okay, by instantiating the parameters, we are using this same module. Okay, so just I don't want to change each and every code. I just want to change the width and depth of my module. Okay, then it will be override, and then it would be applicable for different constant values. Okay, so parameters are declared using parameter keyword. Okay, parameter keyword only we are using them. Okay, so and can be overriding using constant passing. Okay, some constants passing we are using, that means named parameters association we are using. Okay, and macros also we are using, or def params are also we are utilizing. Three overriding techniques. Named constant means you already know, dot width of some value you are mentioning, this is the name based. And then sometimes we are utilizing def param tick width we are utilizing that. Okay, this would be also override everywhere. And then older method like macros we are utilizing. Okay, macros also we are utilizing tick define. Okay, so tick define we are utilizing that width. Okay, this width will be assigned everywhere. Tick width is equals to some 16, all these things we are considering. Okay, that is the defparam and then macros and name based parameters. Okay, see where we are using these parameters are resolved during compilation and elaboration time. Okay, elaboration means in before starting the simulation, any final adjustments are there. This elaboration phase it will take care of that. Okay, that is the before simulation starts. Before simulation starts only, we need to change the parameters, and then RTL not allowing that during running time. Okay, so allowing the same RTL code to generate different hardware configurations such as different bus widths or FIFO depths or counter sizes and pipeline stages. All these places we are utilizing this what parameters already get. So this is the procedural and continuous assignments. How we are storing the procedural and continuous assignments. Okay, so we know that continuous assignments that is for combinational circuits, and procedural assignments you also know that. Okay, so that is for sequential circuits. Most of the times we were utilizing the sequential circuits. Okay, so here procedural continuous assignment means so we are using some force and release. Forcibly we are applying that. After that we are releasing. That means whatever the register is there, we are forcing to apply the net type. Whatever the net type is there, we are forcibly applied to the register type. Okay. So maximum we are utilizing the different techniques here. Okay. Some behavioral compilation, all these things. Just see one by one. See what are procedural continuous assignment. That is the temporarily forced signal values. Okay, we can override existing logic and then test and debug the hardware behavior. So, but we can use temporarily, right? So I can't hold entire module, so entirely to execute all the modules. So I can't able to store, capable to hold that value. Okay. So just for simple purpose, I want to hold the value. So just how we can say that? Can you see my bag? I will go for a washroom and then come back again. So just for time only, I will take care of that. So, and then whole day you need to take care of their luggage means that is difficult, right? Okay, so same way here also. So the procedural continuous assignment is the temporarily forced signals we will apply that. Okay, so then why we need this one? Sometimes during verification or testing, so we want some temporary signals overriding. Okay, suppose a is there, that I want to override that value. Okay, some fault injections we are using that, or forcing reset we are applying that. Okay, so sometimes I am not getting the value, forcibly I will reset that, so my system is hangs. Okay, what I need to do that, control alt delete, and then I will see the forcible reset. So then only my system will be running again. Okay, that is the purpose we are using that. Sometimes the corner cases bugs are not identified there. Okay, so without modifying your RTL, you are changing the some variables. Okay, so that is the purpose we are using procedural continuous assignments. Okay, so what are the main types? Assign, deassign. So assign, deassign is for only registers purpose. Okay, that means wherever register variables you are utilizing, in output some range you are utilizing, output range some y you are assigning there, or output range some data you are assigning there. Okay, for this only assign and deassign we will be using. Where we are using this assign keyword we are utilizing in our data flow model. That means continuous assignments purpose we are using the assign keyword. Now the another keyword called deassign. Okay, so deassign means, so sometimes it will hold the value, after that it releases that value. Okay, that is the reason we are utilizing this deassign value. Okay, and release our force. Okay, so just see that procedural continuous assignment. Okay, so assign or deassign for register only we are utilizing that. Okay, temporarily override the procedural assignments. Okay, where we are utilizing the range we are utilizing in the procedural assignments only, right? So procedural assignments means inside the always or initial, inside the initial we are utilizing this range data type, right? Range data type I am utilizing always inside the always block and inside the initial begin block. Okay, because it's storing the value, it is capable to store the value. Okay, so that is the reason we are giving that. So at that time I am not utilizing the assign keyword. Okay, so you are utilizing the value. Okay, so then assign keyword that is for only wire type. Okay, so wire type only I am utilizing the assign keyword. How I am saying that wire type only? Suppose AND gate you can take that input A comma B. So input you are not mentioning anything means it will take wire automatically. And then output also I will mention that wire. Okay, Y. So then assign Y equal to A and B, right? So in this way I will consider that. But if you take reg means, okay, reg y you can take means, so then I will use this inside the always star I will utilize that, and then y equal to a and b I will assign directly without using any assign keyword, because inside the always begin block. Okay, so this AND operation will be taking place. Whenever you are changing the a value and b value, then your output will be changing. That is the meaning of always. It will continuously repeating that. Okay, but here what I am utilizing this assign keyword for the register name. Okay, then I will hold the value temporarily, and again after assigning the value I will deassign the register name. Whatever the register I am utilizing, that register name I am what it called deassign that. Okay, so that is the reason I am considering here. See, the here example. Look at here. So module registered deassign concept assign deassign example he is considering that. Okay, so then reg day1. Day1 is my register variable. Okay, that means procedural assignment purpose I am utilizing this reg. Okay, so inside the initial begin I am utilizing this one. D equal to 5 and D1 is equal to after 7 times delay I am utilizing this one. But forcibly I am assigning that D1 equal to 5. So D1 equal to 3. Initially I am assigned 5. Okay, but another initial begin. Okay, D1 equal to 3 I am utilizing that. See here, two initial blocks are utilized here. I told you, if you are utilizing two initial begin blocks, the simulator is taking which initial block I don't know. So the simulator is which initial block is taking first I don't know. Then you may take the D1 value first, after that deassign that, then 10 cycles delay, then 20 value will be taking that. Okay, 0 at simulation time, D1 will be taking that. Okay, at 0 at simulation time, D1 equal to 5. After that 5 seconds, so it is taking that D1 equal to 3. Okay, and then after 5 seconds, it is deassigned that. Okay, and then we will see the output. Okay, Just execute this program after the class. Okay, so then you will get to know what is the output you are getting. Okay, then force or release. Okay, so sometimes I will use that force, so you can use overriding method very strongly. Okay, so any assignment, override any assignment type, either wire or range, you can assign anything. Okay, so strongly override any assignment type, either wire or range. Okay, so here force signal I am utilizing that some value I will consider here. Okay, force signal name A, I will take the value 10. Then after that I will release the signal. Release signal name. So sometimes where we are utilizing means, see why this force or release is important in your debugging time. I want to inject some values forcefully. At that time I will utilize this one. So some corner cases bugs are not identified that. At that time forcibly I will inject the error. So then I will identify where I am getting that corner bug error. Okay. So that is the fault injection methods we are utilizing that. And then protocol testing purpose, verification purpose only we are utilizing this force and release. Okay. Same thing. Same assign, deassign, how we are utilizing means same way force and release also we are utilizing this. Okay. So then here range D1 and then wire D2. Anytime, anything we will override. Okay. So wire also we can override assign D2 equal to 3 and then some force release we are taking. See, forcefully I am setting the values for D1 and D2 because it is not touching the 3 and 4 values. Then I am forcefully setting this value. Then after that release the D1 and D2. Okay. So D1 and D2 value will be released and then I will get these values. And then after releasing that, again the original values will be taking place. Okay. So this is the force and release. See, force reset I am utilizing that. That means generally how we are utilizing that, always at the rate passage clock we are utilizing, right? Okay, so this is the passage clock q equal to d, but forcibly I am utilizing that q equal to 0. After that releasing the q value. Okay, so q value 0 is not taking. Why? If we are reset condition only, during reset condition only the q value will be 0, right? But here q value will be 0. Why it is 0 is maintaining? Okay, why 0 we are setting that means I am forcibly reset that because I am not getting the value, my system is goes hang and then I want to reset that value. My simulation goes hang, I want to reset that simulation. At that time forcibly we are setting the values. Okay. So priority order and so what is the highest priority we are having? Okay, so priority means what is that value we are having? Force, highest priority we are having, and then next assign and deassign. After that procedural assignments, okay, and then continuous assignments. So most priority force we are giving. Okay, if you apply the force to the any variable means, then it is taking first. Okay, after that normal values will be considered. That means you already written one example, right? D1 is equals to some 5 you are considering, and then force D1 equal to 3 you are considering. Then which one is considered first? This one only considered first. After that it is releases the force value, then it is going to normal value. Okay, so sometimes they are saying that first check this value, first check this value it is working or not, then after that we can check the normal value at that time and utilize that force condition. Okay, so this force will be utilized that. Okay, so whenever I want to set some value and I want to check some priority value, that at that time the force will be utilized. Okay, assign and deassign, that is the next level. After the force we can assign and deassign. So this would be applicable to what? Register type only. The force will be applied to everywhere, register and then net also. Assign is applied to only reg. Okay, so override strength is the strongest for force. Okay, force or release is the highest priority, that is the strongest priority in your module. Okay, and then override is that medium length. Okay, so that means assign and deassign. After the force and release only we are assigning the assign and deassign. Okay, and then procedural assignments, so it is the next. So temporarily storing the values, right? So this assign and deassign is temporarily storing the values. See here, full signal override. If you apply the force means everywhere any value is there means that will be override. Okay, first this value only is considered. Okay, so most of the common time we are utilizing this force and release only. Assign and deassign conditions are not utilized because this assign and deassign you are utilizing means you may get confused because you are utilizing the data flow model or any other types. So because you are applying the register assignments, okay, that register is utilized in the procedural assignments only. That is for sequential circuits only, right? Okay, but you are using this assign to reg means that reg is capable to store the value. Most of the times I am utilizing in the inside the always begin block or initial begin block, but here I am utilizing normally, then I may get confused. So this register is utilized for procedural assignments or continuous assignments. So that's why I'm not utilizing this assign and deassign. Okay. If you use wire type model means, then you can use the assign keyword, right? Wire type model you are utilizing the variable name, you are assigning the net type means most of the times we are using the assign keyword only. Because data flow model, what is the reason we are utilizing the data flow model? Most of the combination circuits only. Because we are giving the input and immediately I am getting the output. Then wire can't store any value. That's why assign we are utilizing. That assign will be getting the value immediately. Now you are applying this assign to register means that register I am utilizing uh, the initial begin block or always block. That is for procedural assignment. But procedural assignments are utilized for sequential circuits like some flip flops, latches, all these things. Okay, I may get confused, right? That is the reason I am not utilizing this assign and deassign. Most of the cases I am utilizing the reg, force and release. Because this force and release we are applying for both, either register or wire. Okay, so no problem. Clear? Any doubt in this?
Also,
Okay. So common verification uses where we are using the force means, so I want to forcibly set the clock should be 0. Okay, so that is the force clock equal to 0 because clock is continuously varying, right? Every time 1 0 1 0 1 0 in this way the clock is assigned, right? So clock is continuously toggling, then it will never goes to 0 state. Okay, then I am utilizing this force keyword, then my clock should be maintained 0 for particular time period. Okay, so and then in during the protocol's time, my slave is sending the ready signal, then only master is completing the transaction. Okay, so master is going to the transaction phase and sending the data. But unexpectedly, your slave is not responding or not setting this ready signal to high. Okay, at that time I am utilizing this force keyword and forcibly set that ready equal to 1 because I can't wait more time. Okay, I will wait some time. I have also some patience here. I have also some tolerable value. So I can tolerate some extent only. Okay. So then after reaching my threshold value, then I will what it called. So I'm reaching to my extent. Okay. So that's the reason we are using the force keyword, right? And then some errors you are injecting. I need to know where the error is exactly coming. Then I am injecting this force error parity error 1 bit. Then up to that it is getting error means so you are not getting the value at the output side means okay there is an error before the lines. Okay, so you are placing some 100 line force priority error equal parity error equal to 1. Then up to the 100 line you are getting this value at the output side means then there is no error up to 100 lines. Okay, then change that line. Again you can place another 100 lines. Then check that is there any error getting. Then after that you can got the value. So this value is not appearing at the output side means then there is an error in between the 100 to 200 lines. So then you need to identify that. In that way I will identify my errors. Okay. So this is the summary. You can study this. Okay. So procedural continuous assignment for temporary overriding purpose only we are using, and assign and deassign keyword is used for reg type only. So we can temporarily override the values. Okay. So that is the things here mentioned. And force and release mechanism is the stronger override method. It is applied for both wire and reach. Okay. So including the procedural and continuous assignment because continuous assignment for wire and procedural for reach. Okay, so many times I'm repeating these points. Remember, okay, and then where we are utilizing this means debugging time. Debugging time, some fault injections at this time, some reset and force we are utilizing. I want to reset my configuration. Okay, at that time I'm utilizing the force. And assign deassign so after deassign or release the signals are written to original driving source. Okay, whatever the original values you are having that will be moving to that. It's like an interrupt line. You are studying that continuous you are interestingly studying your the RTL coding all these things but you got some call that is an interrupt. Okay, after after take the call and then after ending the call you need to get back to your study. That is the thing we are utilizing here. Okay, force and release is the highest priority assignment. So because we need to verify our simulation time, so that is the highest priority which is applying for that. Okay, these are the strings. Okay, what's the time now? Okay, so tomorrow we will see this.